nature has her very own universal indicators, compounds that are different colors in different pHs. And one example of that is the hydrangea, which grows blue or pink depending on the pH of the soil that it's growing in. And you can, in principle, affect the color of the flower by adding lime to the soil to make it more alkaline, or pine needles or something like that to make it more acidic. Now, a really convenient example of a universal indicator in nature comes from purple cabbage. Next time Mom brings home a cabbage and says, "Look, Johnny, what we're having for dinner tonight," you can say, "Sorry, Mom, can't eat that. I need it for my science project." What you do is you take this cabbage and chop it up and then just soak it in water for an hour or two. And what comes out is a purple liquid. And I've taken some of that purple liquid and I've put it inside to a series of test tubes. And what we're going to do is we're going to take a look at least semi-quantitatively, the pH of a series of different household ingredients. And we're going to do them going from a strong base to a weak base to nothing, to a weak acid to a strong acid. And for our strong base, we're going to look at Drano. So let's take a look at Drano. Remember, Drano is sodium hydroxide. And so I'm just going to pour a little bit of Drano into the test tube, and we're just sort of pouring some in to see the effect. We're not really concerned about the concentrations exactly. Obviously, the concentrations, the pHs are going to depend on exactly how much Drano I put in, but you can see that that's turned from purple to a fairly nice greenish yellow. So that's the strong base. And now let's look at a weak base. Bicarbonate of soda, baking soda, is a good weak base. So let's put some baking soda into test tube number 2. Give this one a little more of a swirl. Okay, so that's the weak base. So now we've gone from yellowish green to blue, and purple is the neutral. For our weak acid, let's take a look at a shot of vinegar. Remember, vinegar is acetic acid solution. So we'll pour in a little bit of vinegar. And now we have this scarlet color, so that's pretty nice. And finally, I couldn't think of a strong acid that you might have in your house readily available. So what I have here is some 1 molar hydrochloric acid. And roughly speaking, 1 molar hydrochloric acid is the same pH as your stomach. So this is what happens when you eat cabbage. When it hits your stomach, it turns a very deep red. So the cabbage juice, once it hits your stomach, turns a very deep red. So you can see now that we have a series of different colors. This is one compound. My guess is that the purple color comes from a kind of compound called an anthocyanin, related to chlorophyll. If you've ever noticed in the fall when the leaves turn colors, what happens is the chlorophyll is being catabolized. The plant is sort of getting all its chlorophyll back and storing it up, reusing it, and storing it up for next year. And what's left over is the anthocyanin, which is why the leaves turn sort of a purplish red color. Anyway, so again, nature's universal indicators, you can get different colors, and now you can use this as a scale for measuring a bunch of other things. For instance, pop has carbonic acid, and if it's cola, it's got some phosphoric acid. Soap is the salt of a carboxylic acid, so it's going to be a weak base. And milk of magnesia is magnesium hydroxide, so that's going to be a strong base. Sodium chloride, remember, is not very acidic or basic at all. It's essentially neutral. And ammonia, you can mop your floors with this. Ammonia is a weak base, so we'd anticipate that if we put it in the tube, it would come out to be roughly yellow. So that's about all I have to say today. Go home, play with them, be careful with them. Obviously, some of these things like the ammonia or like the Drano are very dangerous, but if you work with these and you're careful and you wear the proper eye protection and that sort of thing, I think you can have a lot of fun for essentially no cost.